So now we solve section B of CBSE class 12 2026 paper. Okay, this is set 1. Where is the pen? I forgot the pen. Okay, section B. Okay, section B. Okay. Section B का question number 17, number A. It is a coming from current electricity. Okay, and it is a conceptual question. Okay, it uses the basic idea of Kirchhoff's law. It tests your knowledge of Kirchhoff's law. This is C, this point is B, this point is A. Okay, the EMF of this side is 6 volt and the internal resistance R1 is 1 ohm. Okay, there is a current I passing from C to B. Okay, the EMF of this side is 4 volt and the internal resistance is 3 ohm. Okay, so you are asked find the potential difference between the points B and C. You have to find the potential difference between the point B and C. Okay, so it's a very interesting question and a very good question. Okay, so you first of all you see current flows from C to A. Okay, that means the internal resistances R2 and R1 they are connected in series, and the EMFs E1 and E2 they are in opposite directions. So that is one point you need to keep in mind. Okay, so if that is one point you have to keep in mind, then how do you use all the conditions here to get the value of the potential difference between the points C and B. Okay, so it is like this. It's not a difficult question, but you can try to solve it. Okay, first of all you see one thing, we begin from the higher volt. Okay, E1 minus, say the current is I. Okay, current I flow कर रहा है in this line. E minus I into R1 minus E2, ठीक है, because they are opposite, minus क्या होगा I into R2, okay, is equal to 0. because इसके साथ ये इंटरनल रेजिस्टेंस जुड़ा हुआ है, इसके साथ ये इंटरनल रेजिस्टेंस जुड़ा हुआ है, तो हम इसको ऐसे लिख सकते हैं. ठीक है, तो अब देखो माइनस आई आर वन माइनस आई आर वन माइनस I into R1 plus R2 is equal to कितना होगा माइनस E2 माइनस E1. E2 का वैल्यू कितना है 4 minus 6, that is equal to minus 2. So minus minus gets cancelled out, so I is equal to 2 by R1 plus R2. R1 कितना है 1 plus कितना 3 plus 1 4, so 2 by 4 that is equal to 0.5 ampere. सो करंट जो फ्लो कर रहा है इस ब्रांच में वो कितना है 0.5 एम्पियर. ठीक है, नाउ इफ यू कैलकुलेट द पोटेंशियल डिफरेंस बिटवीन द पॉइंट्स B and C, so it is very simple. Okay, you begin from this point BC minus E2 minus IR2 minus BB is equal to 0. ये हो गया. ठीक है, अब BC minus BB कर दो. BC minus BB is equal to E2 plus I times of R2. E2 का वैल्यू कितना है 4 प्लस I का वैल्यू कितना है 0.5 into 3. ठीक है, तो ये कितना आ गया, it is 5.5 volt. Okay, 5.5 volt. So this is done. Okay, next और में B आता है. B क्या बोल रहा है, a battery of EMF 21 volt and an internal resistance 3 ohm is connected to a resistor. If the current in the circuit is 3 ampere, find number 1 the resistance of the resistor, number 2 the terminal voltage of the battery. Okay, so there are two things. One is an external EMF of 21 volt and an internal resistance of 3 ohm. Okay, and they are connected via resistor. If the current भी दे दिया है 3 ampere वाला, तो आपको निकालना क्या है, रेजिस्टेंस ऑफ द रेजिस्टर ढूंढना है. तो ये एक्चुअली जो है ना ये फेमस है 17 का है ये B. We know I is equal to E by capital R plus small r. ठीक है, फाइंड क्या निकालना है हमको, फाइंड द रेजिस्टेंस ऑफ द रेजिस्टर में कैपिटल R ढूंढना है. So capital R plus small r is equal to E by I. So capital R कितना हो गया? E by I minus small r. E का वैल्यू 21 if I am not wrong. E का वैल्यू 21 है. I जो है इसका वैल्यू है 3 एम्पियर. ओके. माइनस स्मॉल r जो है इसका वैल्यू है 3. Okay, so 7 minus 4 is 7 minus 3 is 4, so 4 ohm. So internal resistance, so the external resistance is 4 ohm, and the terminal voltage of the battery. Terminal voltage का जो relation वो दिया है ना, V E minus I times of R. E का वैल्यू 21 minus I का वैल्यू कितना है? I का वैल्यू है 3, small r का वैल्यू दिया है 3, so it is 12 volt. Okay. That's the answer. Next question में explain why diffraction of sound is more common in daily experience than that of light. Okay. अब साउंड का जो डिफ्रेक्शन ऑफ साउंड का जो वेवलेंथ है वो क्वाइट लार्ज है. ठीक है. अगर ये लार्ज है तो ये दे आर इजीली डिफ्लेक्टेड अराउंड लार्ज ऑब्स्टिकल्स. ओके. एंड अराउंड ऑब्स्टिकल्स एंड ओपनिंग्स. सो दैट इज व्हाई वी आर साउंड इज having more diffraction and light is having short wavelength. So it requires small openings and obstacles to undergo noticeable diffraction in case of light. Next question is mass defect क्या है भाई? ये सब मैंने सॉल्व नहीं किया, आपको पता है. Next question, question number 20 क्या है? A particle of mass capital M at rest splits up into two particles of masses M1 and M2 having non-zero velocities. अगर एक particle of mass M अगर वो split up होता है, एक कोलिए फर्स्ट का इलेक्ट्रिक कोलिशन कोएफिशिएंट का जैसे बॉम्ब है स्प्लिट अप हो रहा है, सो total linear momentum is conserved. So इसमें भी total linear momentum क्या है? Conserved है. They are of equal and opposite signs. Okay. Calculate the ratio of de Broglie wavelength. Okay. Associated with the two particles. So de Broglie wavelength का वैल्यू कितना है? क्वेश्चन नंबर कितना है ये? क्वेश्चन नंबर 20. या लैम्डा इज इक्वल टू h by p. ठीक है. ये है लैम्डा इज h by p. So lambda 1 by lambda 2 is equal to h by p1 by h by p2. But p1 is equal to p2. आंसर क्या होगा? 1 होगा. ठीक है. So ये हो गया. So how are charge carriers created in an intrinsic semiconductor? By the process of thermal excitation. Okay. So this is how. So the some electrons when they get some energy, they jump from the valence band to the conduction band, and they leave holes in the valence band, and as a result, holes and electrons are created in a semiconductor. Okay, this is a brief answer. So the answer is written already in the solution set. Okay, I have written it here. So this ends section B. Okay, so thank you. Now we'll go to the next section, section C.